coming back to our triangle, because that's why we're talking about this.
I'm back in Greek school.
You got your angle in here. We've called that theta, right? And then the thing we introduced, the big thing, was we named all of these sides in relation to theta, right? So the first most important side is the longest one, the one opposite the right angle, which is the hypotenuse. And you remember that word from Pythagoras, also a Greek guy, okay? Then you've got these other two sides. This one's next to or adjacent to our angle. Okay? And then this one was facing the other way. Okay, so he's opposite the angle. Okay? Now, because you've just drawn this up, I'm going to use this as an opportunity to tell you something a bit new from yesterday. We didn't mention it. We sort of alluded to it, but not really. We use these three names of sines to talk about particular ratios, right? And we call them sine, cos, and tan, right? Sine, cosine, tangent, okay? And we said they always attach to an angle, right? That's right. Okay, now, SOHCAHTOA, I'll write that down again, is our mnemonic device for remembering which sides are in the ratios that matter. So, for instance, sine goes with O and H. So it's opposite O over H. That's opposite on hypotenuse. So we wrote down this, right? Opposite on hypotenuse by the same kind of technique. We've got cos, which is adjacent on hypotenuse. Okay, and then our last one, TOA, that's opposite on adjacent. So this is just bringing us back up to speed from yesterday. Here's a new thing for you, okay? I'll get a new color out, in fact. Have a look at our triangle that we've just drawn there. Oh, here are my colors. Now, on this triangle, because it's right angled, and you've got this this theta over here, okay? Theta might be 10, or it might be 20, or 30. Who knows what it is, but I'm just calling it theta. A bit like algebra. You know how we just put in pronumerals and letters to talk about numbers when we don't know what they are. Now, we know that the angle sum of every triangle, even if it's not right angled, right? The angle sum of every triangle is 180, right? So let me just write that down. Angle sum of a triangle is 180. So now the question I just want to pose to you very quickly is, well, this one's 90. This one's theta, whatever that is. What would this one over there be? The one I haven't named yet. Okay. Now, because we know what they're all supposed to add up to, okay, I'll just put a question mark there first, okay? If I add all of these up, I should get 180, right? So let's just see what happens. I've got whatever that angle is, right? I'll add it to theta, and I'll add it to the right angle, which is 90 degrees, right? And they should all add up to 180 because it's the angles of the triangle, okay? Yeah?
Is it? Because wouldn't it be like, you're trying to get to 180, you've already got 90, and then the other two angles are the same. It would be like 45, 55.
Now, they may be the same, but they're not necessarily. That's right. You know, if this one was not 45, this would be something else. We'll look at that 45 one a bit later. That's important, but only works sometimes. Now, I'm trying to work out what this question mark is, right? That's what I'm after, okay? So I can rearrange this, yeah? Have a look at this. I could take 90 degrees away from both sides. I could do that. So I'd have, whatever that angle is, plus theta, and you're going to be left with, on the right-hand side, 90 degrees. Okay, now the last thing I have to do to get that question mark, that unknown angle on its own, is, what do I do to both sides? I should take away theta. The reason I know it's take away, minus, is because I got a plus there. So I want to undo that. Okay? So if I take away theta from that side, I'll just be left with the unknown angle. If I take it away from this side, I get this. 90 degrees minus theta. Okay, so I'm actually going to put that in there now. Okay, that's 90 degrees minus theta. Okay, now this is very important. Let's just quickly have a think about like an example of this. Okay, and those of you who had a look at what we did last night will know this already. Let's pick a theta. Let's pick a theta. Okay, so here's the same triangle. Okay, and what was the example I gave before? 20 degrees, for instance. So I got 20 degrees down here. So according to this, what we've just gone through here, this other angle should be 90 minus theta. 90 minus 20, which is 70. 70 degrees. And you can add it up to check, right? 20 plus 70 plus 90, sure enough, it's 180, just like you expect. Okay? There's something very important here. Come back to this diagram, okay? We've already noted that sine theta equals opposite on hypotenuse. Opposite on hypotenuse, okay? But now imagine you're from the point of view of this red angle now. So I've changed position, I'm standing over here, okay? If I wanted to work out cos of that angle up there, cos of this angle, the red one, what's cos? Be careful, okay? Because now that we've switched sides, right? Yeah, it's this one on this one, right? This one over this one. Let me put some letters on here. Let's call this A and B and C. I think that's what we called it yesterday, okay? So sine theta would be opposite on hypotenuse. It'd be, sorry, go back to blue. It'd be B on C, right? Yes? Now when I do this one, cos of this angle, it'll be adjacent on hypotenuse. It will also be B on C.
Is that A on C?
Huh. No. Because, see, now my opposite and my adjacent have switched around because I'm looking from the point of view of this guy, right?
So they can switch around, but the hypotenuse can never.
That's right. That's exactly right. The hypotenuse is always stuck there, opposite the right angle. He's always longest side, and there's only ever one. But adjacent and hypotenuse depends where you're standing, right? So look at these. These two guys here, these are really important, okay? And in fact, that's what we were looking at last night, for those of you who did. So here is this guy and this guy, which apparently are the same. And in fact, this is why cos is named what it is. Let me just write this out for you. I'd love you to write this out too. Sine theta equals cos of 90 minus theta. Okay? And the example we gave down here was, for example, sine of 20 degrees should be equal to cos of 70 degrees. Now, I want you to go back to yesterday's notes. And we named all of these, but we noticed they were abbreviations, right? We said this is sine, we said this is cosine, and I said the co stood for something. It's a little prefix there, which means, does anyone remember? Can anyone see it there?
Complement.
It means complement, right? Two angles are complements when they add up to 90 degrees. Like these two, or like these two, or any other pair of angles you like to add up to 90. So, for instance, what if I said this? Sine of, I'll give you another angle, sine of 30 degrees. It should be equal to cos of, now what's the complement of 30? It's 60, right? Because again, you can add these up, right? And they'll be the same. Let me give you another one. Sine of 40 equals cos of, now what's the angle that they're going to add up to? It'll be 50, won't it? 40 plus 50 equals, that's right, they add up to 90. So they're complements, and they're complements, and these guys are complements. Now we're going to do one more. The one Tom mentioned, actually. What if I made this one over here 45? What's the complement of 45?
45.
Also 45. Huh. Okay. Now you can get your calculator out. And you can find out what all of these numbers are. It'll give you some weirdo looking decimal. And then you can check all of these on the right hand side and they'll be the same. Okay, yep.
So for example, is sine 40 always equal to cos 50?
Yep.
Alright.
Every single time. Okay. Now I'll just dwell on this one because Tom mentioned it before. What triangle would this look like? What would this look like?
Equilateral.
It would be, it'd be isosceles, yeah, because you got your right angle. We talked with all in right angle triangles, right? This would be 45, but you already told me the complement of 45 is 45. You got base angles equal, so that means these guys are equal, right? So for instance, you might have 1, 1. If you do Pythagoras, you'll find out that that's the square root of 2. Okay. So if you did sine 45, it'd be opposite on hypotenuse, 1 on root 2.
So what's the square root of like?
Okay.
What's that? The square root.
The square root of 2.
Yeah.
1.4.
Oh no,
something.
like
Yeah.
what is it like? No, what made you do that?
I did Pythagoras in my head, and because I've seen this triangle 1,000 times, so I know what it's equal to. Okay. Cos 45 in the same way would be, it's adjacent on hypotenuse, right? Adjacent on hypotenuse. It's also this number. You can check it out. It's like 0.7 something. Okay. Okay. Well done. Rule that off, and let's have a look at a question, and let's do it together because all of this is going to feed into that.
Yeah, rubber does not work.
Yeah, this sucks really badly. Let's get a. This will help. Yes, Dad.
So what was the answer to the 90 minus?
It depends on what theta is.
Okay.
So here's a whole bunch of example answers.
So wait, so that's just the answer, right?
So this is the big important thing here.
Yeah, is that
Right.
is that your final answer?
Yeah, that's what I was trying to show. Well, why sine and cosine? Why is it? What does that have to do with anything, right? Like you need to know why things are named what they are, and this is why it's named what they are.
So
Okay? And here's a whole bunch of examples.